Hi, I'm Shweta, and in this short video, I'll show you my supply chain optimization model project, which has two mixed integer solvers, a clean repo, and a demo that you can run in one command. So I will quickly go to my GitHub. So here is my GitHub, and I have created a repository named Supply Chain Optimization Model for this extra credit software. So this is the repository layout. So as you can see, everything is organized here in just a few folders. SRC folder, this is where my Python code is available for both the models. Then demo has a single script where the data is given to test the models and get the outcomes. And then we also have gitignore and requirements text for the dependencies. And this is a README file describing the project supply chain optimization model. So we'll quickly go to SRC and see the two models. In this folder, as you can see, we have three files. In it, this just marks the folders as a Python package. Then we have plant location. This is the strategic network design model. And then we have the second model, that is aggregate planner. This is tactical production planner. Now we'll go to the first model, that is plant location. So this model one is a capacitate plant location. Here I have imported pulp, uh, numpy, matplot, and I have then defined the class as plant location here. So in this here solve method, I have passed four inputs, that is fixed opening cost, the shipping cost matrix, regional demand, and the plant capacity. We have two decision variables, that is x and y. Y here is binary, which represents one as plant opens, zero otherwise like plant closed, and x is the amount shipped from plant I to region J. The objective is simple: find like fixed cost plus transportation cost. So then I have added demand satisfaction constraints for every region and capacity constraints for every plant. A helper called summarize prints the total cost and the shipment plant here. Now we will go to the model number two, that is aggregate planner. Here also I have imported pulp, numpy, and matplot. So model 2 is the aggregate planner, and it balances workforce, production, inventory, overtime, and back orders across multiple periods. Key variables here are like W for workers, H stands for hires, F for fire, P stands for production, I stands for inventory, and B is optional, backlog, and O is overtime. This objective adds up regular labor, higher fire uh, cost, and inventory holding, overtime, and backlog penalties. So constraints ties everything here. So the first one is workforce balance from month to month. Uh, then the second one is production capacity, which equals worker times rate plus the overtime. That is regular capacity plus the overtime capacity. And then the third one is inventory balance, where it meets the demands and clears all the backlogs by the end. So just like the first model, here also summarize method prints a neat table of cost and decisions. So we can run it in VS Code and Google Colab both. If you want to run it in VS Code, you have to install pip 3, and you have to run it via command Python 3, the file. Uh, and today I'm going to show how to run it in Google Colab here. So for Google Colab also will install this pip via, we'll do pip install pulp. So here while doing it via Google Colab, firstly I have uploaded the files from here, and then I have uploaded this code of my models aggregate planner and plant location. Now I will install pulp pip, and then I'll install the required. And then here I have inputted the data for the demos of both running plant location and running aggregate planner, and we got the results. Here are the results. So this is for plant location where the optimal cost is 9580, where the fixed is 8800, and the other one is 780. And now here is the results for second model, that is aggregate planner. The optimal cost is 3550. And here is the diagram of that. So we get the plant location result, and the first uh, two plants are open. And total cost, like I said, 9580. And here the total cost plus monthly workforce hire, production inventory and backlog all optimized automatically, and we got the results for that, like I said, 3550. So now to wrap up or to summarize, this repository has two pulp uh, mixed uh, uh, two pulp uh, mixed integer solvers, uh, and where the plant location answers like where and how to ship, in aggregate planner answers how to schedule production and workforce. Uh, this code is lightweight, fully open source, and runs only with one command. So that's all for today. Thanks for watching.